So in the last session, we have studied a theorem. For all A and B element of R, absolute value of AB is same as absolute value of A into absolute value of B, and absolute value of A square is same as A square. And if C is greater than 0, modulus of A less than or equal to C implies and implied by minus C less than or equal to A less than or equal to C, and minus of modulus of A is less than or equal to A less than or equal to modulus of A. And we use this theorem to prove the famous triangle inequality. And the triangle inequality says that if A and B are two real numbers, absolute value of A plus B is less than or equal to absolute value of A plus absolute value of B. The sum of two sides of a triangle is less than or equal to sum of the other two sides. Okay, the same thing. So, we have to prove this triangle inequality. How can we prove this theorem? We are given that A and B are real numbers. If they are real numbers, by the previous theorem says that look at the last result, minus of modulus of A less than or equal to A less than or equal to modulus of A. So I have minus of modulus of A less than or equal to A less than or equal to modulus of A. Similarly, B is a real number, so that I have minus of modulus of B less than or equal to B less than or equal to modulus of B. Add these two inequalities so that we will get minus of absolute value of A plus absolute value of B is less than or equal to A plus B less than or equal to absolute value of A plus absolute value of B. Okay. Now look at the second statement of this theorem. If C is greater than 0, this one. If C is greater than the third one, if C is greater than 0, then absolute value of A less than or equal to C implies and implied by minus C less than or equal to A less than or equal to C. Okay. So now look here. I'm taking C as absolute value of A plus absolute value of B. So the previous statement is like minus C less than or equal to A plus B less than or equal to C. Okay. So by the previous theorem we can say that this implies and implied by modulus of the middle term. So modulus of A plus B less than or equal to C. Now what is C? We have modulus of A plus B less than or equal to C is absolute value of A plus absolute value of B. So we have the triangle inequality. Absolute value of A plus absolute value of B is less than or equal to absolute value of A plus B. This is how we prove triangle inequality. Now we will move on to some corollaries of triangle inequality. So we have the triangle inequality on the top. The first corollary is that I have already told you a corollary means a result which follows immediately from a theorem. So if A and B are two real numbers, then the first result says that absolute value of mod A minus mod B is less than or equal to mod A minus B. And the second one says that absolute value of A minus B is less than or equal to absolute value of A plus absolute value of B. So We should prove this. So let's prove the first result. We are given that A and B are two real numbers. I'm writing A as A minus B plus B. Okay, so what is absolute value of A? Absolute value of A is same as absolute value of A minus B plus B. I'm considering this A minus B as a single entry and apply triangle inequality so that I can write this is less than or equal to absolute value of A minus B plus absolute value of B. Now subtract absolute value of B on both sides so that we will get absolute value of A minus absolute value of B is less than or equal to absolute value of A minus B. So take this as 1. Now I will write B as B minus A plus A so that absolute value of B is absolute value of B minus A plus A. I will take B minus A as a single entry and apply triangle inequality so that this will be less than or equal to absolute value of B minus A plus absolute value of A. So subtract absolute value of A on both sides so that we have absolute value of B minus absolute value of A is less than or equal to absolute value of B minus A. Absolute value of B minus A is same as absolute value of A minus B because we know that absolute value of 5 and absolute value of minus 5 are same. Absolute value of A and absolute value of minus A both are same. Okay, so here we have absolute value of B minus absolute value of A is less than or equal to absolute value of A minus B. This I can write as minus of absolute value of A minus absolute value of B is less than or equal to absolute value of A minus B. I will consider this as 2. Now combine 1 and 2. If we combine 1 and 2, we will get minus of minus of absolute value of A minus B. Okay, I will do one thing. I will multiply the second inequality by minus 1 so that I will get absolute value of A minus absolute value of B is greater than or equal to minus of absolute value of A minus B. Consider this as 3. Okay, so combine 1 and 3. 1 is there, 1 and 3. So I will start from this term minus of absolute value of A minus B is less than or equal to, okay, this thing, less than or equal to absolute value of A minus absolute value of B. Now, one says that absolute value of A minus absolute value of B is less than or equal to absolute value of A minus B. Okay. Now, take absolute value of A minus B as C. So, this is of the form minus C less than or equal to something less than or equal to C. Okay. which implies and implied by absolute value of that something is less than or equal to C. So here I can write absolute value of something, means the middle one. Absolute value of A minus absolute value of B is less than or equal to C, means absolute value of A minus B. This is what we have to prove. This is the first result of our corollary. Now we will prove the second one. To prove the second one, what we have to prove is absolute value of A minus B is less than or equal to absolute value of A plus absolute value of B. So I will start from the left hand side. Absolute value of A minus B is equal to absolute value of A plus minus B. Apply triangle inequality to this one. So this is less than or equal to absolute value of A plus absolute value of minus B. And absolute value of minus B is same as absolute value of B. So I have absolute value of A minus B is less than or equal to, this is less than or equal to absolute value of A plus absolute value of B. Thus, we have the second result of the corollary. Now, the next corollary is that this is also a corollary of triangle inequality. It says that if A1, A2, etc. An are all real numbers, they are all real numbers, then absolute value of A1 plus A2 plus etc. plus An is less than or equal to absolute value of A1 plus absolute value of A2 plus etc. plus absolute value of An. This is what we have to prove. How can you prove this? I will not prove this, but you have to prove this. I will give you a hint. Use mathematical induction. So try to prove this result. Now I would like to discuss some problems using triangle inequality. So the first problem is that determine the set A is equal to set of all x element of R such that absolute value of 2x plus 3 less than 7. So as in the previous section, I am taking x is an element of A, and this implies and implied by absolute value of 2x plus 3 is less than 7. Now this is of the form mod A less than C, which is same as minus C less than A less than C. So here I can write this implies and implied by minus 7 less than 2x plus 3 less than 7. And this implies and implied by add a minus 3 throughout. So here minus 7 plus minus 3 minus 10 less than 2x plus 3 minus 3 2x less than 7 plus minus 3 is 4. Multiply throughout with 1 by 2. Since 1 by 2 is positive, the inequality will not change. So minus 10 into 1 by 2 is minus 5. This is less than 1 by 2 into 2x. It is x less than 1 by 2 into 4 is 2. So we get if absolute value of 2x plus 3 is less than 7, x must lie between minus 5 and 2. So our A can be written as set of all x element of R where minus 5 less than x less than 2, or simply this is our open interval minus 5 2. Okay, now I will discuss the next problem. The second problem is same question, determine the set. Here you have to determine the set. B is equal to set of all x element of R where absolute value of x minus 1 is less than absolute value of x. This is our set. You can do the problem in different ways, but I will do the problem in this way. We have absolute value of x minus 1 and absolute value of x. Both are greater than or equal to 0. Both are non-negative. So I am considering this result a less than b implies and implied by a square less than b square. I will use this result. So now I will take an x from b. X is in b implies and implied by absolute value of x minus 1 is less than absolute value of x. This implies and implied by I will square on both sides so that x minus 1 square is less than absolute value of x square. This implies and implied by we have the result. I got this result from here. And we have one more result. Absolute value of a square is same as a square. I will use this here so that I have x minus 1 the whole square is less than x square. What is x minus 1 the whole square? X square minus 2x plus 1. This is less than x square. So you can cancel x square from both sides. So we will get minus 2x plus 1 is less than 0, or this implies and implied by minus 2x is less than minus 1. So you multiply both sides with a minus 1 by 2 so that inequality will reverse because you are multiplying with a negative number. So we will get x is greater than 1 by 2. Okay. So the set B is nothing but set of all x in R where x is greater than 1 by 2. So here you have 1 by 2, x should be here. So this is nothing but open interval 1 by 2 infinity. So this is your set B. Okay, now I will give you one homework. Suppose f of x is equal to 2x square plus 3x plus 1 the whole divided by 2x minus 1 given 2 less than or equal to x less than or equal to 3. X lies between 2 and 3. Find a constant m greater than 0 such that absolute value of f of x is less than or equal to m for all x such that 2 less than or equal to x less than or equal to 3. So this is your homework. Find an upper bound for absolute value of f of x. There is a hint, that is triangle inequality. Use triangle inequality. So do the homework and study well. We will discuss absolute value function more in our next session. Till then, take care. All the best.